r is varies from 0 to, and in this case r is cosec theta. R is from 0 to cosec theta. Okay, and this is r d theta dr divided by 1 plus r square whole 3/. Just two figures of this whole that are done. Okay, now let me do it here. So further, let me now solve it. So first integration is with respect to r, because r is there and r is based by sec theta and something. Let me put here solution we were finding out, and this solution first is 0 to pi upon 4. Okay, now let me put it into bracket. This is r dr upon 1 plus r square whole power 3/. Okay, and this is bracket closed, and limits here, I'm sorry, integration sign okay, 0 to sec theta. Okay, this is d theta then plus sign. Second is 5/4 to 5/2 limits, and second integration sign is 0 to cosec theta, 0 to cosec theta into this value, which is r dr divided by 1 plus r square whole power 3/2 into whole d theta. Okay, this figure is very fine. It's half figure and then error figure. This half figure is error figure. So this is the area which we are taking OABO. This section is devoted to this. And second question is this whole area is to be calculated. So this was divided into two sections in case of coordinates. Okay, now let me take this further. Now let me solve it. So if I take 1 plus r square equal to t, sorry, 1 plus r square, let me take t square. Okay. Okay, let me put this. It will give us differentiating with respect to t. With respect to t, we get, what do we get here? Twice r dr upon dt equal to 2t cancel out. R dr equal to t dt. What about it? Okay. Now I'm not converting the limits, but we will then convert the t variable into the r variable, which is 1 plus r square, and then we will substitute in place of r as sec theta or 0 or whatever. Okay, that is my aim here. Now let me solve it further, or we can change the limits also. So now that's not a problem. Now let me take this value. Okay, so integration of this 0 to pi/4. Therefore, this is if we have changed this is t square whole 2 cancel out t2 is t dt. In the numerator we have that 0 to sec theta, sorry, 0 to sec theta within bracket. Still I'm not integrating. So with that t dt, only changing the variable here. This is t square whole cube whole 3/2. So this is one t cancel out, t square is there. So one point to integrate this separately. Integration of dt upon t square, okay, is equal to -1.3. Right one is we will take this t square numerator will be t raised to power -2. Integration will be t raised to power -2 plus 1 upon -2 plus 1. That means -1.3. This is integration. So then t is to be substituted as 1 plus r square. That means under root 1 plus r square. Okay, so let me substitute that. This is integration of this. Okay, and then the theta. Similarly, the second part, let me, after putting this value, we get here also the same thing. 0 to, this is pi/4, pi/2, and here integration is again 1 point under root -1 1 plus r square integration. This we have done, and the limits are now substituted as 0 to cos of theta into d theta. This is the integration here. Because t here also 1 upon t, and that can also be written as minus 1 upon minus 1 upon t. But t was under root 1 plus r square. So this we considered as 1 plus r square as t square. Integration was there. Then t minus 1 upon t was the integration completely. So t is then substituted as under root 1 upon r square. Now limits are, these limits are substituted then. So finally 0 to sec theta. Here limits are to be substituted. Here 0 to cos theta limits are to be substituted. Okay, so this is the figure. Now let me rub this figure. So please try to understand this integration. What we have done, because what were given to us x0, y0, okay, and x equal to 1 and y equal to 1. That was the rectangle. And that rectangle was in two parts: first section, then second section. First section, second section. They are integrating this. Now let me substitute down 0 to 5 by 4. This value will be minus 1 upon under root. First is 1 plus sec square theta. Well, r is sec theta, but sec square theta will be sec square theta. Okay, and minus sign. Here sec theta for 0 lower limit. We substitute here r 0 will be minus 1 upon 1 to be plus 1 only. Minus sign is already given. It is plus 1 into d theta. Second case is also at the same time 5 by 4 to 5 by 2, and this is also minus 1 upon under root 1 plus cosec square theta and plus 1 d theta. Why plus 1? Because this r will be 0. Then we substitute 0 here, it will be minus 1 upon 1, that plus minus sign. In between, when we put the lower limit, we put minus sign. Minus sign is already there, so it will be plus sign. It is plus 1. Okay, now let me put the limit, solve it further. It is 0 to 5 by 4. What is this conversion? This is, if I take 1 from cos square theta, it will be cos theta equals to cos square theta. Okay, 1 from cos square theta. Cos theta will come in the numerator divided by under root 1 plus cos square. Try to understand. And plus 1 is there into d3. Plus similarly here, this is pi by 4 plus pi by 2, and this is minus, it is sin theta here, it is sin theta, well, it is 1 upon sin square theta. Sin square theta, when square root is cancelled out, and it will come in the numerator. It is minus sin theta upon under root 1 plus sin square theta. Okay, into d theta now. And this plus 1, let me solve this plus 1 and minus 1 and whatever. These two are separated. Let me separately do them. This is plus 1, integration will be theta. In place of theta, we substitute this pi by 4. Pi by 4 is plus sign. So what is the integration of this? Okay. Let me keep it no problem. This is d theta here, that means theta. Limits pi by 4 to pi by 2. Okay, that is integrated. Theta is integrated. This one is also that will integrate. With plus theta, and the limits are 0 to pi by 4. These two are separated. Now let me solve the two integrals which are very this one. Now in this case, if I further write it down, 0 to pi by 4. Now this cos square theta can be written as 1 minus sin square theta. But 1 minus sin square theta, it will be 2 minus sin square theta. It is minus cos theta of under root 2 minus sin square theta. Why? Because cos square theta are written as 1 minus sin square theta. Hence cos square theta is equal to 1 minus sin square theta by trigonometry. So this is 1 plus 1 minus sin square theta. This is 2 minus sin square theta in trigonometry. Now this is plus pi by 4 only. Plus pi by 4. This for 0 0. And plus this value will be pi by 2 minus pi by 4 plus pi by 2 minus pi by 4. This minus pi by 4 plus pi by 4 cancel, pi by 2 only the leftover value from this, these two independent value 1 1. Okay, pi by 2 here. What the second part is, this is plus sign pi by 4 pi by 2 still line, this is minus sin theta upon this is under root 2 minus cos square theta. For sin square theta also is converted into 1 minus cos square theta. It is 1 minus cos square theta equal to sin square theta. Sin square theta is substituted as 1 minus cos square theta. Now, so it is 2 minus cos square theta. Okay, and plus pi by 2 will be the t. Now, in both the cases, in first case, if I take sin theta in the first one, that this is I1 and this is I2. In I1, this is I1 here, this is I2, this is I2. In I1, let sin theta equal to 0. Let me differentiation between cos theta d theta equal to d. Okay, if I change the limits, can we change the limits also? No problem at all. Change the limits. At theta equal to pi 4 will be 1 from root 2. Limits let me change. Limits at theta equal to pi by 4. Okay, and u will be sin pi 4 is 1 to root 2. Okay, and at 0 theta equal to 0. Theta sin 0 is 0, so u will be 0. U equal to 0. So limits in first case, let me write here. This is 0 to 1 from 0. This is minus cos theta d theta. Cos theta d theta is 0. It is minus u under 2 minus d square. U square, sorry, it is u square. It is u square here. Similarly, cos theta, but it will be positive. The reason is, and in I2, and in I2, let sin cos theta, is cos theta equal to v. Differentiating with respect to v, we get minus sin theta d theta equal to dv. Minus sin theta, this is d theta, I'm sorry. Minus sin theta d theta equal to dv. Second case, limits when pi by 2 is there, cos 0 is 0. 0. It will be 0 then. It will be 0 at theta equal to pi by 2. Cos pi by 2 is 0, to v is 0. But at pi by 4 it is, so limits let me change. Limits are at theta equal to pi by 2, cos theta equal to 0, 0, sorry, cos v equal to 0, equal to u. Therefore, u equal to, when theta is 0 in cos, for pi by 2, sorry, 0 equal to 0, cos 0. So, u equal to 0. When theta is 0, pi by 2, sorry, theta equal to pi by 2, cos theta means cos 0, so u equal to 0 in this case. And at pi by 4, cos pi by 4 is also 1 for root, and at theta equal to pi by 4, cos pi by 4 is equal to u, sorry, v in this case, I'm sorry, in this case it is v. Okay, so v is equal to, therefore v is equal to 1 for root 2, because cos pi by 4 is 1 for root 2. So here limits are plus sign, but this minus sign is there, so it is 0 to, sorry, 1 from root 2 to 0, and it is dv upon under root 2 minus v square. Now, very good question. Okay, now let me try to solve it. The final answer, pi by 2 are also coming. Now let me write them as plus pi by 2. The solution of that those two values. So there are the three steps. This for this one, and this for second this one, and this pivot is still there. Pivot is also there. This is plus pi by this is this one. Okay. Now let me solve it. What is the integration of this? A square minus under root a square minus b square. But this is under root 2, which is sine inverse. Integration of this will be, or it can be cos inverse because negative sign is there. But this is also negative. Let me put here minus sine inverse u upon root 2. Side one to 0. 0 1 point root yes 0 to 1 point, and this is if I change this. Okay, let me put here first and look up. Limits are here 1 upon root 0. This is also sine inverse. Sine inverse this is v upon root 2 minus v square. So under root 2 whole square. A means under root 2. A means under root 2. This is v upon root 2. Limits are 0 1 point 0. This is plus pi by. This is plus pi by. Okay. What about this one? If I put the upper limit, 1.2, it will be minus sine inverse pi upon, this is sorry, 1 upon 2 on, right? Because u is 1.2, but 1.2 is already 1.2 into 1.2. Sine 0 is 0. This is plus sine 0. The plus lower limit is 0. But for 0 it is 0. Plus, in this case it is 0. This is minus sine. Again, v upon this sine inverse is 1 upon 2 only. Because again 1 upon root 2 into 1 upon root 2. That means 1 upon 2. So this is when sine inverse 1.2 there for pi by 6. For pi by 6 it is, and it is plus pi by 2, which is we are taking minus pi upon 6. For sine inverse 1.2 is pi by 6. For 30 degree sine theta is sine 30 degree is 1.2. So 1.2 is pi by 6 plus pi upon 2 minus pi upon 6 is also minus pi upon 6. There are two values. So what is the sum, total sum of this? Let me write here. The final answer of this question will be pi upon 2 minus pi upon 6. Twice of pi upon 6. This is 1.3. So answer is, let me take 6 LCM. 3 pi minus pi minus 2 pi. That is pi upon 6 only. 3, it is pi by 3, it is pi upon 6 LCM, 3 pi minus 2 pi, that is pi upon 6. This is the answer. Question 12 is done, but has taken time for the coordinate of, but question is of this kind. So this is how we have to do this. Question number 12 we have done. Now let me talk about 13th question, the remaining questions. Now question number 13, what it say? Question number 13 here is this much. Evaluate again son of, we have to convert this into polar coordinates. Y square into d.x.d.y. Okay, over the area outside the circle. Now outside the circle, it will be x square plus y square minus ax or equal to ax max minus ax will be 0 or x square plus y is equal to ax, and outside the circle and inside the circle, which is x square plus y square equal to twice ax. Second circle is this. It says outside the circle is between these two circles. Let me write here. Here the circles are. Take the first circle like this. Let me tell you. This is the second circle. this is second circle here. Okay, so this is the area in between these outside the circle and inside the circle, that in between these two circles. X-axis or y-axis, y-axis. This is the first circle where if I take polar coordinates like this, so here theta will vary from minus power 8 to plus power 8. So this is theta here. Theta is again minus power 8 to plus power 8. Okay. What is r here? R is this ax to 2ax. This is r square equal to this value. I'll just write down the value of r. R can be valued from this. So first is this r. First r was this r square equal to ax. Let me convert that into polar coordinates. So solution. Here x square plus y square equal to as, or r square equal to x r into cos theta. One r cancelled out. R is equal to a cos theta is first. This is first equation. Second equation, r square equal to twice a r cos theta. This is 2 cos theta, because here it is also x. R is equal to 1 r cancelled out. R equal to 2 cos theta. The limits are from a cos theta to r is from a cos theta to 2 cos theta. This is one of the limits. Now y here is r square sin square theta, that is right here, and dx is r.d.theta, that can be there. So now let me convert it. Limits theta varies from minus power 8 to plus power 8. So the area we have to find out between this. Okay, so that is here. Now these two circles are given to us. So let me find out this value. So this r is, we are having 2a cos theta and a cos theta. The value of r is here, r is equal to a cos theta and r is equal to 2a cos theta. This is here r equal to a cos theta to r equal to 2a cos theta. Values r varies from this to this. Okay, and theta varies from 0 to the same thing, 0 to this is minus power 8 to plus power 8. That is, there is no change. So we have to find out this area. So this area is again varying from, if I take this angle, this is power 8 to plus power 8, minus power 8 to plus power 8. So that is the area here. Now this is the first quadrant of this angle. Okay, so that is one of the points here. I'm just talking what is that. I'm noted down all these points. Okay. This is the first section. Now if I take what it says between these two circles, it is above the region here. This is not the region. The region is what? Between these two. So first quadrant of this. What is the question? We evaluate this over the area outside the circle this, and this inside the circle this. Okay, so this can be done in this way. No problem. So minus power 8 to plus power 2 or 0 to power 8. This is the limits here. Okay, so limits we have to substitute 0 to 2a. What the limits here given to us? I'm sorry, I'm just watching the point here. I'm taking my notes. In my notes, I have not noted on this question. This question and this watching is not taking this question note. Between these two circles. Yes, guys. This question is given there. Yeah. I've taken this question. This is 13th one. Okay. Let me take these questions. between the limits, and the limits are given to us. 13th question, inside the circle this and this. Okay, so this is also there. This area will also be there. We will cover. So limits are minus 5/2 plus 5/2. Let me take this question here. So therefore, limits, let me write. Therefore, this solution we are finding out limits are, first limits are minus 5/2 plus 5/2. This is minus 5/2 plus 5/2. Okay, second limits are a.Cos theta to 2a.Cos theta. This is 2a.Cos theta. R we have taken this. And this is y square. What is y square here? Y we have taken, we have to convert this into full quantities. R square sin square into d.x.d.y we write always r.d.theta.d.r into dr. This we have converted into full quantities. Now we can integrate this. Simple question, that's not a very difficult task. Question is absolute y square equal to minus ax or equal to ax, and this is equal to twice ax, then we have substitute the values, converted them into this is y square d.x.d.y over the area of the surface. Okay, no problem. We are not talking about the first quadrant or second quadrant. This is the whole area between these two circles. The circle is smaller because circle is twice a cos theta. Second. Now this we have to find out this area. Let me write that into a proper area. This is minus 5/2 plus 5/2. And let me write that into bracket. This is a cos theta twice a cos theta. The limits are now r square into r, that means r cube here. R cube into dr into sin square theta into d. Okay. Now let me integrate this. This is r4 upon 4. Sorry. Let me integrate this. This is minus 5/2 plus 5/2. And this integration is r4 upon 4. Doing the limits here, which is a cos theta is 2a cos theta. Okay, this is sin square theta into d theta into d theta. Sorry.